Hello everyone, welcome back. So now let's talk about section 3.3, measure of position. So we have 6 parts for this section. We have part 1, the z-score, part 2, quartiles, part 3, percentiles, part 4, the 5-number summary, part 5, outliers, and then part 6, which is box plots. So now let's start with part 1, the z-score. So let's kind of recall practice 2. So in practice 2, when we calculate the percentage of adults have IQ scores between 55 and 130, we look at 130 is how many standard deviations away from the mean. So we use 130 minus the mean, which is 100, and divided by 15. And then we got a positive 2. And then we said is 2 standard deviation to the right of the mean. So this process, we actually call it z-score. So a comparison of a relative standing is the z-score. And then we're going to use the mean and standard deviation with a proper calculation. So a z-score or a standard score for value is obtained by subtracting the mean from the value and dividing the result by the standard deviation. The symbol for standard z-score is z, and then the formula is just value minus mean and divided by standard deviation. We actually used this one already, but to make it more specific, for sample is x minus x bar divided by sample mean. For population is x minus population mean divided by population standard deviation. The z-score represents the number of standard deviation that a data value falls above or below the mean based on the sign we got. So now let's look at the next slide. We're going to do a practice. A student scored 85 on an English test, while the mean score of all the students was 76 and the standard deviation was 6. Then the z-score for English going to be the score 85 minus the mean, which is 76, and divided by the standard deviation equals 4. And that tells us 9 divided by 4, which is 2.25. And then for French, 42. So on French, which is a 42 minus the average is 36, and the standard deviation is 3. So we got 6 divided by 3, which is 2. So since the z-score for English is higher than the z-score for French, her relative position in the English class is higher than her relative position in the French class. However, they're pretty close. It's not look like close if you only look at the score. So 85 compared with 42. Okay, so after we talk about the z-score, let's look at another information. So this is just a sample SAT result, and then this student got 1350, and then if you look at the right circle information, you got a 94th here. So what's exactly the meaning for 94th? So everybody may already know this already, that 94th means this 1350 is above 94% of the students. Um, so this is actually called percentile. Now in part 2, let's talk about a special case for percentile, which is called quartiles. So quartiles divide the distribution into 4 equal groups, denoted by Q1, Q2, Q3. So if this is the, if we look at the picture, this is the entire population. You have 3 numbers to separate the whole population into 4 equal groups. Then starting from the smallest to the largest, we call it Q1, Q2, Q3. And then quartiles, just based on the word quartile. So you can kind of know it's divided by the population into 4. So Q1, the first quartile, Q2, the second quartile, and Q3, the third quartile. And we also need to know that Q2 is the same as median. Because Q2 is the number separate the population into exactly two groups. So this is a value right in the middle. So it's the same as the median. And now after we define the quartiles, let's see how to find the quartiles from a data set. So step one, we're going to arrange the data in order from lowest to the largest. And then now we just count how many numbers we have in the data set, and then we use n to represent it. For Q2, we know it already, it's the median. So we can first find Q2. And then for Q1 and Q3, we first, in step two, we need to look at the position. So we use L represent the position, which is if we look at the first quartile, we're going to use 0.25 n times how many number we have in the data set. In the third quartile, if we have 0.75 as the third as the number, we're gonna times the sample size. So that's the third quartile. And then step three, L is a whole. If L is a whole number, then the quartile is the average of the number in position L and the number in position L plus one. So this position L means the ordered number. So Lth ordered number and then L plus one, the ordered number. If L is not a whole number, round it up to the next higher whole number, and the quartile is the number in the position. So just Lth. After we round it up, then it's Lth ordered number. So now let's look at the example. The example of traffic violations recorded by a police department for a 10-day period is shown below, and then we want to find Q1, Q2, Q3. In step one, I'm going to arrange the data in order from lowest to the largest. So step one, let's write it down. We're just going to rank the data. So it's already been sorted, so no problem. This step check. In step two, let's look at n. N equals 2, 4, 6, 8, 10. So we have 10 values, and Q2 gonna be the middle two values. So 18 plus 19 divided by 2, so that's 18.5. That's our Q2. It's actually the median. And then L for Q1 equals 0.25 times 10, which is 2.5. L for Q3 gonna be 0.75 times 10, which is 7.5. So 2.5 is not a whole number. Then we're gonna round it up to the next higher whole number. So round it up to 3, and then round it up to 8. So 3 and 8. Not a whole number, and then the quartile is the number in the position corresponding to the roundup value. So this means the third value. So Q1. Then we can do step 3. Q1 equals the third value, which is 15. And then Q3 equals the 8th value, which is, so 10, 9th, 8th, which is 22. 22. So let's circle Q1, Q3, and then Q2. Because Q2 is right in the middle of 18 and 19. So now we finished this practice problem. Now let's look at another definition, interquartile range, IQR. The IQR is the difference between the third and the first quartile. So IQR equals Q3 minus Q1. This is also a measure of variability, and this IQR uses the middle 50% of the data value and then calculate the range. So it's called interquartile range. It's similar to the range, but for range, it's highly affected by the largest or smallest value, the extreme values, but interquartile range is not. So this is more like median, kind of robust to outliers, interquartile range. Now we're going to calculate that in IQR for the previous example, which is Q3 minus Q1. And we know Q3 is 22 and Q1 is 15. So 7 is the interquartile range. And now let's look at percentiles. So percentiles are position measures used in most likely education and health-related fields to indicate the position of an individual in a group, just like we mentioned. So if a student got 1350 in SAT, then this number is higher than 94% of the whole student who took the SAT at that time. So percentiles divided the data set into 100 equal groups. And for a number p between 1 and 99, the pth percentile separated the lowest p% of the data from the highest 100 minus p%. So percentile are symbolized by p1, p2, p3 up to p99, and then divided population into these 100 groups. So this is p1. Then separates the 1%, which means we have 1% below. So that's the P1 and the 99% above. For P2, we have 2% below and the 98 above. And for P3, 3% below and the 97% above, so on and so forth. And then for calculation, it's very similar to the quartile because quartile is actually a special percentile. So Q1 is the 25th percentile, and Q3 is the 75th percentile, and then Q2 is the 50th percentile. And that's why if you compare the procedure for computing the quartile for a data set and the procedure for computing the percentile, it's very similar. And then also 3 steps. Step 1, we're going to arrange the data in order from lowest to largest. And step 2, so we're going to look at the position and then check whether the position is whole number or not. So now let's just use this example to check this procedure to calculate the data value corresponding to a given percentile. So still the same data set. So first, step 1, we're gonna sort the data from the smallest to the largest. And 9, 12, 15, 16, 18, so we got a 9, 12, 16, 15, 16, 18, and then 19, and then 20. So we got 22, 24, 25, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all 10 values sorted. So first step done. And then step 2, we want the 30th and 65th percentile. So we're just gonna say L30 equals 0.3 because 30%, right? So we use 0.3 and then times n. So that's going to be 0.3 times 10, which is 3. And then for the 65th, which is 0.65 times n, which is 6.5. So if is a whole number, then the P's percentile is the average of the number in that position and the next number. So so we got a 3, right? So the 30th percentile gonna be the third one and the fourth one, take average. The third value, the third ordered value. So this is a third and the fourth order value. So 15 and 16, and then divided by 2, which is 15.5. That is the 30th percentile. P30. And then if we want to look at the 65th percentile, so which is P65. If it's not a whole number, an integer, then we just round up to the 7th. And then that's going to be our P65, which is, let's look at 1, 2, 3, 4, 5, 6, 7. So 7th number, that's going to be 20. So now we successfully found out the 30s and 65th percentile. And if we look back, the reason we use 0.25 because Q1 is the 25th percentile, and then Q2 is the 50th percentile, and then Q3 is the 75th percentile. They use 25% and 75% here. And now let's look at the percentiles corresponding to a given value x is computed by using the formula, following formula. So now we don't want to compute P30 or P65, and then we just want to look at the value in the data set and then know what percentile it is. So it's given by this formula, number of values less than x plus 0.5, and then divided by total number of values, and then writing up percentage, and then round the result to the nearest whole number. So now let's look at again this example. We have to order this one. So we have 9, 12, 15, 16, 18, 19, 20, 22, 24, 25. And then this is the target value. So number of values less than x, we have 3 values, and then plus 0.5, and divided by the total number we have in the value in the data set, 2, 4, 6, 8, 10. So we have 10 and then times 100%, times 100. So that's going to be 3.5 divided by 10, 0.35. So that's going to be 35. That means this 16 is P35. Okay, so next part, part 4, we're gonna discuss the 5-number summary. We'll start that part 4 in next video lecture. Thank you.